On Monday, Booster 19 lit its engines for the first time. It lasted about 3 seconds. Then it stopped, and everyone online immediately started panicking. I found the culprit, and it is not what you'd expect. Isaacman is proposing monthly flights to the moon. This lunar base isn't just a dream. And NASA and Blue Origin are making sure we're not being wiped off the Earth before it happens. My name is Felix, welcome to What About It, let's dive right in. Starship updates. Monday, March 16th. After weeks of cryo tests, an inspection lift, and more cryo tests, Booster 19 finally lit its engines at Pad 2. Almost immediately, the spaceflight community spotted something in the footage. A puff of white vapor came out of one of the chines on the booster, right as the static fire stopped. The puff was strong and forceful enough to leave a visible blast mark in the ice that had accumulated on the hull. And then the engines cut off. Speculation online went everywhere. Was it a leak, a failure, had something gone wrong? I dug into it and I found the culprit. There is a double vent right there in that exact location on the chine. You can see it clearly in my images, so no panic, nothing went wrong. My read is that this is most likely a COPV-related pressure relief vent routed into the chine. COPVs, which stands for Composite Overwrap Pressure Vessels, are housed inside the chines on the booster and are responsible for pressurizing the propellant feed systems during engine startup, among other functions. A pressure relief vent from a COPV during or immediately after ignition is entirely plausible and consistent with what we saw in the footage. Now the important caveat. Booster 19 rolled back to the production site overnight from Tuesday to Wednesday. It is now in Mega Bay 1 being inspected. Now your question will likely be, what happens next, Felix? Let's take a look together. There is some good news in all this speculation. SpaceX has given us a confirmation. On Wednesday, March 18th, they posted on X and it cleared up at least some of the open questions. Contrary to some speculation out there, this was indeed an aborted static fire. SpaceX confirmed it. They did not give a reason other than a ground side issue. This means that something other than the booster itself caused the problem. For example, the pad itself could be the problem. Maybe a booster quick disconnect didn't seal properly. Maybe a sensor returned the wrong value, triggering an automatic abort. I think we can rule the tank farm out, as that's not much needed during the actual ignition phase of the test. That is excellent news. It means that the booster itself, including the brand new Raptor 3 engines, performed perfectly. The new design proved it's capable of a static fire on the very first attempt. SpaceX also confirmed that all 10 installed Raptor 3 engines lit up correctly. While Booster 19 was on the pad, we got something valuable. Detailed images of the shielding underneath the booster, and it is worth taking a moment to appreciate what SpaceX has done here. The aft dome is covered with heat tiles featuring 2 small raised humps on them. We do not know for certain what the humps are for. They could simply be the attachment points for the tile itself, or they could have something to do with surface texture design to optimize airflow and thermal protection during ascent and re-entry. Got ideas? Let me know in the comments. More remarkable is what is not there. On the version 2 booster, the entire engine section had to be encapsulated in heavy shielding. Every Raptor 2 engine was individually wrapped, the engine bay was sealed, and the whole assembly added significant mass to the bottom of the vehicle. Raptor 3 changed that completely. The new engine has an actively cooled powerhead, meaning it runs cooler and handles re-entry heat far better than its predecessor. The result is that SpaceX was able to strip away almost all of that shielding. What remains is shielding for the thrust vector control actuators on each engine, some shielding around the methane turbopump and other components, plus the tiles covering the aft dome. Small boxes and sleeves are all that is left. That's it. The engines themselves are exposed. Less mass, better performance, cleaner design, this is exactly what version 3 was built to achieve. Speaking of things that process a massive amount of new information very quickly and give you exactly what matters. Oh yeah, this is my reminder to share what I found. Information can be overwhelming. Endless news feeds make it tough to find what you actually care about, but fortunately there is help. Meet today's sponsor, Sift, the world's first AI-native news agent. Incredibly easy and free to use. Type whatever matters to you. Sift analyzes that topic. Across the world, in every language, it summarizes what you care about. This is how you get a bigger picture. And then there is the sidebar. The topics you follow are added here, and you will automatically get summaries on the most important news on those topics. If you're on the go or prefer audio, Sift updates are also available in a podcast format. You guys know what my favorites are. If you like what you see in the digest, you can click to explore more and easily see how everything connects. Best of all, it's free to download on both Android and Apple devices. There is also a browser version at sift.ai. Super easy to use and loved by many around the world, it's consistently ranked as one of the top news apps in Europe. Get started by searching and downloading Sift AI News Agent on the App Store or Google Play today and stay on top of the news you care about. And here comes some news that is very close to my heart. The old Gateway to Mars sign at Starbase may be coming back. SpaceX painted the wall facing Highway 4 black a while ago. Now aerial images show the original letters emerging from storage and being moved around the site. Whether this is a full reinstallation of the sign or just a repositioning of the letters on site, we do not know yet. But the idea of that sign coming back up illuminated against the South Texas night sky with Starship towers in the background is a pretty fitting image for where this program is right now. And before you're quick to write a comment, this is still the gateway to Mars. SpaceX never cancelled the goal of building a city on Mars. Instead, they added a step in between. The lunar base efforts are there to work together with NASA, gain know-how, and test things closer to Earth. It does make a lot of sense, and SpaceX still plans to send Starships to Mars within the next 6 years. Over at the expanding launch site, Pad 1 construction is picking up pace to make exactly these things happen soon. More structural parts for the Pad 1 orbital launch mount frame arrived at the pad this week for staging. And additional sheet pile work was completed around the new flame trench under construction. Every time we do a new flyover at Starbase, more progress becomes visible. All this reporting isn't possible without an aerial view. If you want to see how SpaceX is doing at Starbase from the air, just like Jordan does, visit redlineheli.com/Felix. $25 off for anyone using the link. The Redline helicopter team will show you the same Starbase views our photographer gets on his Starbase flights. Incredible views. SpaceX is fast, really fast. At the pace we are seeing, a second fully operational launch pad at Starbase before the end of this year is looking increasingly realistic. When that happens, SpaceX can prep one vehicle on the pad while the other is processing. And the launch cadence they are targeting starts to become achievable in a very straightforward way. I've visited Starbase 7 times now. Every time the place looks completely different. Over at the production site, Ship 39 appears to be in the process of receiving its engines. If that's true, here is something interesting. It might be that SpaceX intends to skip the thrust simulator stand they recently built at Massey's for Ship 39. Can't do that with engines installed. It is possible SpaceX still has thrust simulator testing planned and simply hasn't gotten there yet. Again, we'll have to wait and see. Meanwhile, at Massey's, the test article Ship 39.1 is still very much in use. As can be seen on Avid Space's cameras, 6 tension rods were installed on the test stand as 39.1 sits on. That looks like preparation for additional structural testing. This is remarkable when you consider that Ship 39.1 has already completed 10 successful cryogenic tests. SpaceX is clearly not done with it. Whatever they still want to learn from this test article, they are going after it. At Slick 37 at Cape Canaveral Space Force Station, progress continues. 8 tower segments are now staged at the pad and ready for vertical stacking. Once the groundwork is completed, stacking should move quickly. And as those segments clear the Roberts Road production area at Kennedy Space Center, it creates room for SpaceX to begin manufacturing and staging the second tower, which will also be erected at Slick 37. 2 towers at one site, the construction process is now visibly beginning. Now for the maybe most important part. What's next for Booster 19 and Ship 39? SpaceX gave us the answer. We are in for the big one now. In the same post where they confirmed that Booster 19's static fire was an abort due to ground equipment issues, they also confirmed the next step. The booster is currently at the production site inside Megabay 1, and it is receiving an additional 22 Raptor 3 engines. Once this is done, they'll roll it back out to the production site for the real deal, a 33-engine static fire. That will be amazing to see, and I think with a little luck, we're around a week or so away from that. Ship 39 is likely receiving its engines and could be heading toward its own static fire in the not-too-distant future. 2 vehicles, 2 paths forward, and the Flight 12 launch window getting closer by the day. We are getting closer to a Starship launch. This will be good. While the SLS rollback to the launch pad was moved to the 20th, NASA Administrator Jared Isaacman shared more details about his vision for the agency's future. In a post on X, he released a video interview outlining the next steps for NASA's push toward the moon and eventually beyond. One of Isaacman's key messages was that NASA needs to remove internal bureaucratic barriers if it wants to move faster. Agreed.
You can't do all those fun, exciting things we want to build a moon base if you don't address all these very real concerns and problems that come up from the workforce where, whether it's policy, regulation, things that are just impeding progress, you have to clear it out and unleash them.
This will be essential if the agency wants to meet the ambitious goal he outlined. We already covered the plans for robotic landers that start building a moon base last episode. Now, Isaacman has added an even more ambitious expectation, a monthly mission cadence starting in 2027. Just imagine that, a new flight heading toward the lunar South Pole roughly every 4 weeks. To be clear, he is not talking about SLS with this monthly cadence, he means everyone. While the moon remains the immediate focus of the Artemis program, Isaacman also emphasized that NASA intends to expand scientific exploration again. In recent years, several science missions were cancelled or scaled back due to budget pressure, and he suggested the agency wants to restore that broader discovery mission. If they manage to become more efficient, they can achieve more with the same budget. He also highlighted 2 technologies NASA is actively developing: nuclear power and nuclear propulsion. Nuclear surface power could provide the reliable energy needed for a crewed lunar base, especially during the moon's 2-week-long nights. This will come in very handy even with permanent sunlight at the South Pole. A nuclear system would reduce the need for massive battery banks, which come with their own technical challenges. Nuclear propulsion, on the other hand, is aimed at much more distant destinations. NASA sees it as a key technology for future missions to Mars and beyond, potentially allowing spacecraft to travel faster and carry heavier payloads deeper into the solar system. Nuclear propulsion's killer advantage is orders of magnitude better propellant efficiency thanks to the enormous energy density of nuclear fission, roughly 1 million times higher than that of chemical fuels. This unlocks faster trips, bigger payloads, missions to the outer solar system, and human Mars missions that are safer and more practical than relying purely on chemical rockets. Speaking of our solar system, we share this space with much more than just the sun, the planets, and their moons. There are countless asteroids mixed in. One day, Earth will be hit by one of them again. It is not a question of if it will happen, but when. Maybe not a civilization-ending one like the dinosaur-killing Chicxulub impactor. Those are rare, and we've already found many of them. But a city killer? Those are far more common, and the name is not nice either. And the uncomfortable truth is we've only found about half of them, and that's just a guess as well. On a cosmic scale, these are tiny. From a human perspective, they are airborne Godzillas. Just the type of thing you never want to encounter. Jeff to the rescue. A new spacecraft concept announced by Blue Origin could give us better cards in this all-or-nothing poker match. If it works, it could become one of the first real tools in Earth's asteroid defense arsenal. The concept is called Neo Hunter, and it's designed to do something no previous asteroid mission has ever done before. It can try 2 different ways of pushing an asteroid off course in the same mission. To understand why this matters a lot, let's take a look. How large is the problem? Astronomers have cataloged roughly 40,000 near-Earth asteroids so far. About 2,500 of them are classified as potentially hazardous. These are objects large enough and with orbits close enough to Earth to pose a real impact risk someday. 2,500 potential killers. 2,500 times total devastation. And that's only what we found already. The good news is that we think we've found almost all of the truly giant ones. For asteroids larger than 1 kilometer, detection is about 95% complete. Those are the civilization-ending impacts, and none of the known objects threaten Earth for at least the next century. But things get more concerning as the asteroids get smaller. For objects 140 meters and larger, we've found less than half of the estimated population. These are big enough to devastate an entire region. The US Congress actually ordered NASA to find 90% of them back in 2005. 20 years have passed and we're not even halfway there. Below that size range is the category that worries many scientists the most, the city killers, objects about 50 to 140 meters across. There could be tens of thousands more of them, most are likely still completely unknown. Their threat is real. We already have a real-world example of what one of these can do. On February 15, 2013, an asteroid about 20 meters wide entered Earth's atmosphere over the Russian city of Chelyabinsk. No telescope saw it coming. It arrived from the direction of the Sun, which is a blind spot for ground-based observatories. It's literally like looking into the Sun, you see nothing. The object exploded in the atmosphere about 23 kilometers above the ground, releasing roughly 30 times the energy of the Hiroshima bomb. The shockwave shattered windows across 6 cities, damaged thousands of buildings, and injured more than 1,500 people. And they didn't see it coming. And on top, that asteroid was tiny, about 20 meters in diameter. Something just a few times larger could destroy an entire metropolitan area. Events like this are why planetary defense has become a serious scientific field. In 2022, humanity finally tested whether we could actually change the course of an asteroid. NASA launched a spacecraft called DART, the Double Asteroid Redirection Test. Its target was a small asteroid moon called Dimorphos orbiting a larger asteroid named Didymos. DART wasn't trying to destroy the asteroid, it was trying to nudge it. The spacecraft slammed into Dimorphos at 6.6 kilometers per second, almost 24,000 kilometers per hour. And the asteroid's orbit changed dramatically, more than 25 times better than expected. The impact blasted over 1 million kilograms of debris into space, creating a long tail of material that telescopes tracked for months. In other words, we didn't just hit the asteroid, we actually moved it. For the first time in history, humanity had measurably changed the motion of a natural object in the solar system. But that mission also revealed something important. Dimorphos turned out to be a rubble pile, a loosely packed collection of rocks barely held together by gravity. The common perception of asteroids is that they are large, solid rocks, like in Star Wars. But that doesn't seem to be the case. Many asteroids appear to be large balls of loose rubble. That matters, because if you slam into a rubble pile asteroid too hard, you might break it apart instead of deflecting it. Instead of one asteroid, you could end up with several smaller ones. So while kinetic impactors clearly work, thanks DART, they are not always the perfect tool. And that brings us to the new idea announced by Blue Origin. A few days ago, the company unveiled a mission concept called NEO Hunter. NEO, by the way, spells out to near-Earth orbit. It's designed around Blue Origin's in-space spacecraft platform known as Blue Ring. Blue Ring is essentially a space tug, a kind of jack-of-all-trades of the space industry. It can carry up to 4 tons of payload. It has the built-in option to generate large amounts of electrical power with deployable 44-meter solar arrays. The power can be used for payloads or Blue Ring itself. The small craft can maneuver across huge distances in space using a combination of chemical engines and electrical propulsion. Most importantly, it's designed to operate not only in Earth's orbit but also far beyond it. And that makes it extremely interesting for planetary defense. The NEO Hunter concept could use this platform to attempt 2 different asteroid deflection techniques in a single mission. The mission begins by approaching a target asteroid and deploying small probes to study it: shape, rotation, mass, and composition. When it comes to deflecting asteroids, one of the biggest problems is that we don't know for certain what they are made of until we get there. Once the asteroid is analyzed, the spacecraft would try the first deflection technique, something called ion beam deflection. Instead of hitting the asteroid, the spacecraft would hover nearby and fire a continuous beam of high-speed ions at its surface. The force is tiny, but it never stops. Over months or years, that steady push can slowly nudge the asteroid's orbit. Think of it less like a punch and more like a constant shove. And now to the spacecraft's party trick. If the gentle approach isn't enough, Neo Hunter has a destructive backup plan. The spacecraft itself becomes the impactor. At the end of the mission, the roughly 5-ton spacecraft would slam into the asteroid at around 10 kilometers per second. In other words, Neo Hunter is designed to try the polite option first and, if necessary, fall back on brute force. It was his fault, he didn't move. Instead of committing to a single deflection strategy years in advance, the spacecraft could adapt once it actually sees the asteroid up close. But there is an important caveat here. Right now, Neo Hunter is just a concept. It is not a funded mission yet, and no launch date has been announced. But it points towards something that could dramatically change planetary defense. Commercial spacecraft platforms that can respond quickly when a threat is discovered. And detection is still our biggest weakness. Even today, more than 14,000 asteroids large enough to devastate an entire region are still out there undiscovered. To close the gap, NASA is building a new space telescope called NEO Surveyor, scheduled to launch no earlier than 2027. Instead of looking for reflected sunlight, it will detect asteroids by their heat signature, allowing it to find dark objects that are almost invisible to ground-based telescopes. Heat signature in this case refers to the asteroid's temperature being different from that of space rather than to a cozy, warm asteroid. But it's enough to make them visible. Within 5 years, it could discover 2/3 of all remaining large near-Earth asteroids. So where does that leave us today? In some ways, humanity is in a better position than ever before. We've proven that we can change the trajectory of an asteroid. We have a dedicated asteroid-hunting space telescope on the way. New concepts like Blue Origin's Neo Hunter suggest that commercial space companies could eventually play a major role in planetary defense. But we're not fully ready yet. Thousands of dangerous asteroids are still undiscovered, and Neo Hunter is just an idea. Several of the most promising deflection techniques have never been tested in space. Planetary defense is no longer science fiction, but it's also not yet an operational capability. Right now, we're still building the first pieces of the system that may one day protect the entire planet. Because the next asteroid impact isn't a question of if, it is a question of when, and the work we're doing today will determine how prepared we are when that day finally comes. And that's it for today. Smash the like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our brand new Raptor emblem design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. And if you want to know how SpaceX is planning to build a self-sustained moon base in the next 10 years, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode.